Okay, 26 to 30. You're trying to prove your parents you did well in English class. Your test scores are the following. Which measure of central tendency should you use? Mean or median? So mean, we're going to have to average all four scores by adding them all up and dividing by 4. So let's do that right now. We'll clear. So we'll add up all the scores. And divide by 4. So we get a mean of 76.75. Okay, the median is when you line up all the scores in order from smallest to largest, 65, 65, 77, and 100. You find the middle score. Now there is no middle score because there's 4 of them. So you're going to have to average the middle 2 scores then to get the median. And so we would do 65 plus 77, right? And divide by 2. It's 71. Okay, so the median is about 71 point something. So clearly we're going to use mean because we want to convince our parents that we did really well in English. That's the higher of the 2. Next problem says, you like to live in a place that doesn't have extreme weather, so which of these 3 cities should you choose? Well, if you look at just their average mean temperature, you can't choose between the 3 cities. They're all the same, but they're not the same. If you look at Ames, Iowa, that's the one you're going to choose because it has the lowest standard deviation. And a low standard deviation means the data doesn't deviate very far. So the temperature doesn't get very far above or below 61. So the lower the standard deviation, the less extreme the weather. Okay, number 28 says, be able to read and interpret histograms. Well, histograms are different than bar graphs because they always have an interval along the x-axis. So you can see this is home runs hit. How many home runs are hit? So from 1 to 10 is the interval. 1 home run, 8 home runs, all the way up to 10, 11 to 20, okay? You also notice that each of these bars is called a bin, and the bin width is 10. This is 11 to 20, that's 10 wide, 10 wide, 10 wide. They should all be the same bin width. And all these bars should be connected because you can see the data is 1 to 10 and it goes right to 11. Bar graphs don't have to be connected. The bars can be separated. On the y-axis is the frequency. Okay, so you count. So if I'm to read this histogram, I'm going to say that bar 1, there are 14 people who hit between 1 and 10 home runs. If I go down all the way to the last bar, that looks like about 1 person hit between 41 and 50 home runs. So that's kind of what you do with a histogram. The next problem here says we're at a carnival, and 200 people played this game. 10 of them did win a first place prize. 14 of those 200 won second, 25 won third. What's the experimental probability of winning? Well, winning, you'd have to look at how many people actually won. Well, that's 10 people won first prize, 14 people won a second prize, and 25 won that. So that's a total of 49 people won. 49 people out of the 200 people won a prize. And so that's the probability in terms of the experimental probability. It's what actually happened. It's not theoretical probability. So if you calculated this as a percentage, it ends up being 0.245 or 24.5%. Any of these 3 are acceptable answers for the probability of the experimental probability. Okay, and the last one is a coin toss. And they want to know what's the probability that you get a tail or you roll a 5 on a die. Now, these 2 things have nothing to do with one another. So what we're going to do is we're going to find individually probability of a tail, which is 1/2, or means add probability of a 5, which is 1/6. So this guys have made a mistake. It doesn't say or. It says and. And when you see and, you should multiply. We're not going to add them, we're going to multiply them. Okay? So the final answer will be 1/12. This is the probability that you would flip a tail and also roll a 5. And that's it for this video.